Hello everyone, welcome to the course on electromagnetic theory and interference. In this session, we will continue our discussion about transverse magnetic mode. So in the previous session, we saw the wave equations in TM mode. Now we are going to see three possibilities depending on the value of k or omega and the integers m and n, which are a part of this wave equation. Okay, and we know that for cutoff mode, the k square value, okay, we are going to consider k square as omega square into mu epsilon as from this expression, and that is going to be equal to this k square term is nothing but equal to this entire summation term, that is m pi by a the whole square plus n pi by b the whole square. So in this, if I substitute this condition here, my propagation constant will be 0. There is no propagation, then attenuation, phase constant, everything is going to be 0 because of this particular relation. So what we can infer, the value of omega that causes this is called cutoff angular frequency. So at cutoff, we are understanding that there is no propagation is taking place. So the cutoff angular frequency, we are going to just replace omega by omega c and find it. So omega, if I found, I should take 1 by root of this term mu epsilon, and this entire term is multiplied by the square root of m pi by a the whole square plus n pi by b the whole square. So the second case is the evanescent case. That means my k square value, that is omega square mu epsilon, I am going to consider is less than the this particular component m pi by a the whole square plus n pi by b the whole square. If I substitute k value less than this, obviously I will get propagation constant as positive. So positive means what is the meaning? I will get gamma. There will be no propagation actually. Only the wave will get attenuated. And if there is no propagation means what happens? Beta is going to be 0. So these non-propagating modes are called evanescent mode. Okay. Now let us see the third possibility, that k square value is greater than m pi by a the whole square plus n pi by b the whole square. If I substitute the value, k value larger than this, what happens? Since there is a negative term, I will get a root of negative some value. So if we already know square root of some negative term, I will get an answer in complex form. Okay. So if the answer is coming in complex form, obviously there is propagation taking place, and there is no attenuation there, since we are concentrating on a lossless dielectric medium that is present inside the rectangular waveguide. And the phase constant, how will I find? Phase constant means this gamma is going to be equal to beta, and we already know this gamma is, I am going to take it as beta, then k square is larger, we told, right? So this entire term interchanges. K square comes first, then minus n pi by a the whole square plus n minus n pi by b the whole square. Okay. So this is the case. This third case is the only case in which the propagation is taking place, because in all the field components we know that it is having a factor of e power minus gamma z, and we know gamma is nothing but j beta. So we have to understand that for each mode which is characterized by the set of integers m and n, there is a corresponding cutoff frequency that is called Fc. So each mode has a different cutoff frequency. That is major takeaway. So what do you mean by cutoff frequency? It is the operating frequency below which attenuation is taking place and above which only propagation is happening. So we are going to find the cutoff frequency. So if you think cutoff frequency in this manner, we can very well say that waveguide is acting as a high pass filter. Okay, in high pass filter only we have this behavior. Below the cutoff there will be attenuation, above the cutoff there will be a passing of the signals, right? So the cutoff frequency I can get from the same omega c that we have found earlier. Since omega is equal to 2 pi f, I can find fc by dividing omega c by 2 pi. Okay, in this entire term. So after taking pi as common from this expression, so pi square out of the root turns out to be pi and pi get cancelled, and we are left with 1 by 2 root of mu into epsilon into multiplied by root of m pi by a the whole square plus n pi by b the whole square. We already know that 1 by root of mu epsilon is nothing but u dash, that is the phase velocity of uniform plane wave in a lossless dielectric medium. Okay, and from this expression we can get the cutoff wavelength, that is lambda c. Lambda wavelength and frequency are related by this term, that is it is equal velocity by frequency, right? So we are considering phase velocity divided by cutoff frequency fc. So if I substitute the cutoff frequency expression here, u dash and u dash get cancelled, then I am left with 2 divided by root of m pi by a the whole square plus n pi by b the whole square. So we have so far seen the three different possibilities by the values of k, m and n, cutoff, evanescent and propagation. In the first two cases there is no propagation at all. Okay, only in the third case where we consider k square is greater than this particular term, we are having the propagation, and we have defined the cutoff frequency and the cutoff wavelength. I hope you enjoyed the session. Thank you everyone.